Here's integrated 3. This is problem 9-103. And it says one intercept on this graph of this cubic is negative 5, 0. Use this information to calculate all of the x-intercepts. So if the intercept is negative 5, then x plus 5 has to be a factor. So I'm going to get out my area model, and I'm going to do Polydoku. I got an extra box there, whoops. So I put the x plus 5 on this side, and then you take the first term and stick it in there. And then I didn't know anything else yet, but I asked myself, x times what equals 12x cubed, and I came up with 12x squared, and then I used that 12x squared times it by 5, that gave me the 60x squared. And then what you do is you go, let's say I don't know what goes in this box yet. I ask myself 60, see this is an x squared and that's going to be an x squared. These are my x squareds. So I go 60 plus what equals 55. Well, 60 plus negative 5. So then that kind of forces this up here to be negative 5 because I got an x here. That has to be negative 5x. And then negative 5x times 5, that's negative 25x. And then I didn't have this number yet. I did this ahead of time. But I can look at negative 25x, and I want to see what I would have to add to that to get my negative 27x. And it turned out to be negative 2, so that forces this to be a negative 2 because negative 2 times x is negative 2x. And then 5 times negative 2, that's negative 10. So that actually all worked out and it went in evenly. So what I do from here is I'm going to rewrite it in a different form. I'm going to say, because this times this equals what's inside the box, because it's an area model, it's like length times width equals what's inside, I can write it as x plus 5 times my quotient, which is 12x squared minus 5x minus 2. That equals this whole cubic. Okay, this times this equals the cubic. So now I've just got the cubic kind of rewritten in a somewhat factored form, but I can go farther with this one. This one's a quadratic, so I'm going to just use area model. You probably can't see. So I stuck in the 12x squared right here, and then you stick the constant here, and you go that times that equals that. And then I want to find, and I have to add up to negative 5, x. And so I thought of two numbers that multiply to make negative 24 and add to make negative 5. And the 8 and 3 worked, and then I stuck them in the box. And then you look here and you go, well, what can go into 12 and 3? Well, 3x. And then I'd have to multiply that by 4x to get the 12. And then I'd have to multiply, that has to be a 1. So hopefully you know how to use the area model box. So this thing factors out. Now I've got my x plus 5, but this quadratic factored into 4x plus 1 times 3x minus 2. And if I want to find where the intercepts are, I set that equal to 0, because that's where y is 0. And so if x plus 5 equals 0, then x is 5. If 4x plus 1 equals 0, then x is going to be negative 1/4 because I solve it, right? I do these in my head. That's why it doesn't show any work. And this one, I would go 3x minus 2 equals 0. So I would add 2, and then I divide by 3, and that's how I'm getting the 2/3. So these are my 3 intercepts, well, besides the one that they gave me. And so I can write them as 5, 0, negative 1/4, 0, and 2/3, 0.